Hello, I have a question. 5.3, number 33. Most of you guys have already done it this semester already, but there's still have a question on this one. It's irrational functions. This is the one I have a code with holes. I've done a few um, videos already with these types of problems, so here's one more to add to your list. Uh, but remember, this is I have a code with holes, so we're going to graph this rational function. It's actually quadratic over quadratic. Okay, so the first thing we need to do is make sure we factor the numerator and denominator. And the reason I do that first is because I want to check to see if there's any holes in it. So if you factor the top, it's x plus 4 times x minus 3. And on the bottom, it's x minus 3 times x plus 2. So so x plus 4, x minus 3 on top, x minus 3, x plus 2 on the bottom is the way it factors. And so indeed there is a common factor that needs to be canceled out. So it reduces down to x plus 4 over x plus 2. So the good news is it reduces down. The bad news is I got to remember to put a hole in there later on. And as a matter of fact, there is a hole at x equals 3. Because x minus 3, what makes that 0 is 3. So the good news, though, is I reduced it down to a linear over linear. So starting with the I, intercepts, x-intercept, set the numerator equal to 0, and that would be x equals -4. So at -4, there is an x-intercept, and it crosses because of the odd degree. And the y-intercept is you set x equal to 0, so it'll be 0 plus 4 over 0 plus 2, 4 over 2, which is 2. So there's a y-intercept at 0, 2. Now the horizontal asymptote is going to be 1 because it's a linear over linear, and so the degrees are the same. So you divide the leading coefficients, and the leading coefficients are 1 and 1. So the horizontal asymptote is y equals 1. And remember, when you have a linear over linear, it does not cross the horizontal asymptote. And again, if you don't remember to do that, you set x plus 4, x plus 2 equal to 1, and then you multiply the x plus 2 to the other side, then you end up with x plus 4 equals x plus 2. The x's cancel, and you get 4 equals 2, which is untrue. But just remember, linear over linear will never cross. So next thing you do is your vertical asymptotes, and that sets the denominator equal to 0. And so x equals -2. So we'll put a vertical asymptote at x equals -2. Now remember, horizontal asymptote is in behavior, but the vertical asymptote is where it's undefined. So next thing is the C, the crossing the horizontal asymptote doesn't cross. So the oblique asymptotes, we don't have oblique asymptotes. As a matter of fact, none of your homework problems will have obliques. And the only way you're going to have an oblique is when the degree on top is bigger than the bottom, which we don't have this case. But so now we're ready to just trace the graph. And the question is, do we have enough? Yeah, since it's got to become magnetized towards the asymptotes, it's got to cross this point right here. There's no way it can be like this, because it would have to become turned back up and become magnetized. But if it did that, there is the x-axis. It would have to cross the x-axis at some point. So it has to be going crossing to the other direction, like so. Okay, so it magnetizes towards this asymptote, crosses, comes down and magnetizes towards this end of negative. So it starts positive and it goes through there. Magnetizes on both ends. And remember, it does not cross the horizontal asymptote. And the only thing we have to remember now is the hole at x equals 3. So you count over 1, 2, 3. Now, the biggest thing that students have is they know there's a hole at 3, but they don't know what to do with it. They'll put a dot here, and they'll put a hole there. All is wrong. Okay? What you have to do is the hole represents a point on the graph that there is a hole there. So you take a piece of the graph away at x equals 3, wherever that graph is. Now the graph may be, wherever the graph turns out to be, that's why you wait to the last. You got to figure out where the graph is going to be located. So after you locate the graph, take a point off at 3 and put a hole there, and that completes the graph. So So number 33 does have a hole in it. So, and that is it.